electrochemical anodization technique. Electrochemical anodization is a versatile and powerful surface treatment technique. It improves corrosion resistance, aesthetic appeal and functional performance. Advancements in nanostructuring and hybridization are expanding its potential in medicine, energy and advanced manufacturing. Future research will likely focus on smart and multifunctional anodic layers. The principle of anodization technique. The anodization process requires a simple electrochemical cell comprising of anode, that is the metal workpiece to be anodized. Cathode will be typically made up of stainless steel or lead or platinum, and the electrolyte consists of acidic solution like sulfuric acid, oxalic acid or phosphoric acid depending on the metal. The instrument used for the anodization technique is DC power source. It provides the necessary potential difference. So the mechanism of electrochemical anodization: initially the sample is polished, for example titanium, that is polished and then etched in Crald solution, that consists of nitric acid and HF in a particular composition. Then anodization is done using DC power source. The electrolyte contains organic and inorganic electrolyte containing F minus. After applying the potential, the surface morphological studies will be carried out using SEM. The main parameters in the anodization process are applied voltage, annealing temperature and electrolyte. So the electrochemical anodization mechanism: at the anode, the metal atom loses its electron and forms the metal cation. These cations react with the oxygen species to form metal oxides. So best example is aluminum. Aluminum undergo oxidation and releases electron and it forms the aluminum Al3 plus cations. Al3 plus cations during the that is anodization process, so it combines with O2 minus and it forms Al2O3. So aluminum oxide is formed. Whereas at the cathode, reduction occurs, typically producing hydrogen gas. This H plus and 2 electron gives hydrogen gas. The process results in a stable adherent oxide layer on the metal surface. The figure shows the variation of annealing temperature after the anodization of the titanium alloy, titanium 6 aluminum 7 niobium. We have varied the annealing temperature from 450 to 850 degrees centigrade. The same picture, the first one shows the as formed sample, then the sample annealed at 450 degrees centigrade, 600 degrees centigrade, 700 degrees centigrade, 800 degrees and 850 degrees centigrade. From these same morphologies, the substrate retained tubular structure up to a temperature of 800 degrees centigrade. When the annealing temperature increased to 850 degrees centigrade, then this tubular morphology breaks. So on the right hand side, XRD, that shows the XRD patterns of titanium nanotubes on titanium 6 aluminum 7 niobium substrate. It shows that the samples annealed at 450 and 600 degree contain anatase phase, whereas sample annealed at 700, 800 and 850 degrees centigrade contain mixture of anatase and rutile phases. The figure shows the effect of electrolyte concentration, that is influence of water content on the formation of nanotube. So we have varied the water content from 0 to 40 degrees centigrade. So the first one, water content is 0, then T and TA 10, 20 and 40. So the water content is increased. As the water content increased, the tube diameter is increased. The tube length, that is decreased as the water content increases. So that shows from these two pictures. Water content, increase in water content, tubular diameter increases and tube length decreases. So the decrease in nanotube length and increase in nanotube diameter with increasing the water content, that is revealed from the HR same images. So influence of voltage on the formation of nanotubes. So the voltage is varied from 10 volt to 30 volt. By applying a 30 volt on the surface of the titanium alloy, self-organized nanotubes were formed, and the diameter of 100 nanometer and length 250 nanometer, whereas the applied voltage, that is 10 volt, then the diameter of the tube is only 30 nanometer, and for 20 volt the diameter of the tube is 80 nanometer. So by increasing the voltage, the diameter of the tube increases and length remains constant for all the three the applied potentials ranges. As already I told, the anodization, the important parameters for anodization process are voltage. If they apply the voltage or higher voltage, then you will get a thicker oxide layer. Current density, that also affects the growth rate and pore size. Temperature also influence the morphology of the sample. There is lower temperatures improve oxide hardness. Electrolyte composition, so that dictates pore structure and growth behavior. And time is also important. Longer durations yield thicker films but may increase porosity. And you need to stir the solutions, ensure uniform ion distribution. Precise control is critical for reproducibility and quality. So the anodized surface after the anodization, I already told you the applications of anodization, that increases the or improves the corrosion resistance of the material so that it protects against environmental degradation, and also it increases the wear resistance of the material, because the hard oxide layers resist mechanical damage, and it acts as an electrical insulator, that is ideal for dielectric layers in electronics. And also the anodization process enhanced addition in the field of, for example, dyes, paints or biomolecules. It also improves the biocompatibility, especially true for titanium based implants. These properties can be tailored by adjusting the process parameters. In addition, so the applications of the anodization process, that is applicable to aerospace, architecture, medical devices, electronics, automotive industries. So the advantages are environmentally friendly, no heavy metals are involved, durable and adherent coating, can be dyed in multiple colors, compatible with further functionalization. But the limitations are limited to only specific metals. Porous structure may require sealing. High voltage may induce breakdown. Now we will see the demonstration for anodization experiment. The electrolyte is prepared by weighing the suitable chemicals. The specimens were sonicated to clean the greases and other surfaces, and the electrolyte is treated to obtain a homogeneous solution. Then, in order to fix the voltage using this DC power source, you can fix the voltage. So here you can fix the voltage at 80 volt. The electrodes are mounted to the stand and it is connected with the instrument. The experiment is started. You can remove the sample and can do the surface morphological studies using scanning electron microscope.